Welcome to Architecting the Agentic Enterprise, moving beyond chatbots to autonomous, multi-agent production systems. This presentation is targeted at tech leads, architects, and AI engineers who are ready to move past zero-shot prompting and build systems that truly act. The numbers are real. Gen AI startups secured over $20 billion in 2024, and by 2028, Gartner projects that 15% of daily work decisions will be made by agentic AI. This tutorial walks through the architecture, the frameworks, the security risks, and the governance model required to get there responsibly. Slide 2. Exception. Context lost. Why Gen AI alone is not enough. The left panel captures the core limitation. A zero-shot LLM receives a prompt like write a comprehensive research report from start to finish and returns output. But that output is bounded, linear, and prone to hallucination. Andrew Ng captures it perfectly. Asking a zero-shot model to do this is like asking a human to write an essay from start to finish without using the backspace key. No iteration, no correction, no context memory. The right panel shows the agentic alternative. True agentic AI operates through a continuous while loop. While the goal is unmet, the system perceives its environment, plans its next action, then acts. It loops, calling external tools, reflecting on failures, revising its plan. The distinction is fundamental. Gen AI answers the question, what should I create? Agentic AI answers, what should I do next, and how do I get there? Slide 3. System. Set autonomy level. The 6 levels of agentic control. Not all AI systems are equally autonomous. This spectrum maps 6 discrete levels from fully human-driven to fully agent-executed. Level 1. Code. A human decides every step and every output. The AI is not involved in control flow. Level 2. LLM call. AI executes a single prompted step, still human orchestrated. Level 3. Chain. AI executes a hard-coded sequence of steps, deterministic, no deviation. Level 4. Router. AI chooses which path to take, but cannot loop or cycle. Level 5. State machine. AI executes with cycles and loops. This is the beginning of true agentic behavior, where the system can revisit steps based on outcome. Level 6. Autonomous. The AI decides the output, decides which steps to take, and decides what steps are even available. Full agency. The system boundary between level 4 and level 5 is where production enterprise AI actually begins. Slide 4. Executing design patterns of agentic systems. This slide shows what a real agentic execution loop looks like in practice. The agent receives a user request. Run a competitor analysis. It loads memory, the context of what the user needs. It decomposes the task into steps, web search, data extraction, digest formatting. It invokes a tool, browser-based search with query Q3 financial reports. The tool returns a 404 error. Here is where agentic behavior diverges from a simple LLM call. The agent reflects. It critiques the failure. It suggests a fallback. Use Wikipedia search instead. It retries successfully. It then routes the retrieved data to a specialist summarizer agent for the next stage of processing. The key insight. The agentic system orchestrates the complete data flow, maintains context across every step, and adapts its plan dynamically when conditions shift. No human intervention required. Slide 5. Katsura. Exona System Theoretic Architecture, MD. The 4 components of an agent. Pulling from system theory, a production-grade agent is composed of 4 interconnected modules. Perception and grounding. The PG layer senses and processes raw inputs from the environment into structure percepts the agent can reason about. Action execution. The AE layer, the effectors of the system, uses tools to execute physical or digital actions. API calls, database writes, file operations, browser automation, interagent communication. The IAC layer, the structured peer-to-peer communication protocol enabling coordination in multi-agent setups. This is what allows a planner agent to delegate to a specialized executor agent. And learning and adaptation, the LA layer, the feedback loop that observes performance, learns from experience, and synthesizes insights back into the agent's strategy and world model. These 4 layers are not optional enhancements. They are the minimum viable architecture for a system that behaves reliably under real-world conditions. Slide 6. NPM Install Agent Framework. Why use a framework? Many developers initially prefer raw chat completions, API calls, a stateless design that feels simple. But the left side of this slide shows what that actually produces. A tangled graph of function calls, error handlers, retry logic, counter breaks, and state tracking variables that cross-reference each other with no coherent structure. Raw prompt engineering creates brittle, Ad hoc systems. A proper agent framework adds 4 structural capabilities that production requires. Agent abstractions, standardized definitions for control flow and reflection, so every agent in your system behaves predictably. State management and memory, persistence across sessions, fault tolerance, and retrieval augmented generation integration. Orchestration, multi-agent coordination, and intelligent routing between LLM calls. And observability, logging, tracing, and debugging tools specifically designed for the failure modes of LLM tool use. Because these failures are categorically different from traditional software bugs, frameworks provide the structural solutions necessary for production reliability. Slide 7. Diff frameworks, Crew AI frameworks, LangGraph frameworks, BAI. The framework comparison. 3 frameworks dominate enterprise agentic development. Here is how they differ. Crew AI. Role-based collaborative intelligence using the concepts of crews and flows. Written in Python. State managed through event-driven process orchestration. Ideal for multi-agent research teams and specialized business process automation. LangGraph. State-centric, graph-based multi-actor workflows. Also Python. State managed through a central persistence layer with checkpointing, meaning the agent can pause, be inspected, and resume. Ideal for stateful conversational assistant and complex decision trees with human-in-the-loop validation. BAI. Modular, flexible workflows with pre-built agent types. Unique in offering full feature parity across both Python and TypeScript. State managed through serialization. Ideal for scalable IT and HR automation with tight integration into IBM Granite and Watsonx. Agent frameworks offer different structural paradigms, language support, and state mechanisms optimized for specific enterprise applications. The choice is determined by your architecture, not by popularity. Slide 8. Import Crew AI. Orchestrating role-based intelligence. Crew AI is completely independent of LangChain, built on high-level simplicity with precise low-level control. The core primitive is the agent, defined by 4 properties: a role, for example, senior data analyst; a goal, uncover actionable market trends; a backstory, the context and expertise that shapes how the agent reasons; and a tools list, the external capabilities the agent can invoke, such as a web search tool. This structure is not cosmetic. The role and backstory directly influence how the underlying LLM interprets tasks and generates outputs. A well-defined backstory is functionally equivalent to a precision system prompt. Beyond individual agents, Crew AI supports 2 coordination modes: autonomous crews, open-ended collaborative intelligence optimized for research and multi-step analysis; and flows, granular, event-driven control for decision workflows and API orchestration where strict sequencing matters. The architecture on the right shows how agents and tools chain into sequential tasks, converging on a final outcome. Slide 9. Import LangGraph. Building stateful multi-actor applications. LangGraph is built by LangChain Inc., but operates as a completely independent library. Its design is inspired by distributed computing models, specifically Progel and Apache Beam, which gives it production-grade reliability characteristics. 4 capabilities define LangGraph's enterprise value. State-centric architecture manages application state through a central persistence layer with checkpointing. The state is the source of truth at every node in the graph. Graph-based execution defines tools as nodes and establishes directed edges and conditional paths between them. The graph is your workflow, readable, inspectable, and modifiable. Production trust powers production-grade agents at major enterprises including LinkedIn, Uber, and GitLab. This is not experimental infrastructure and human-in-the-loop, built-in capabilities through state checkpointing, ideal for systems that require human validation before irreversible actions are executed. The graph can pause at any node, surface state to a human reviewer, and resume based on approval. For compliance-sensitive workflows or high-stakes decision systems, LangGraph's HIDL architecture is the most mature solution available. Slide 10. Import BI. Deploying scalable agent workflows. BAI is an open-source framework developed by IBM, designed to construct production-ready multi-agent systems with robust enterprise controls. 2 technical differentiators set it apart: language parity, full feature support across both Python and TypeScript with no capability gaps between the two. For organizations with polyglot engineering teams, this eliminates the need to choose a single language for agentic development. Broad model support, optimized for IBM Granite and Llama 3.x, but deeply integrates with DeepSeek R1, Grok, OpenAI, and Llama. The framework does not lock you into a single model provider. The AI's architecture is modular end-to-end. Pre-built React agents for rapid deployment, fully customizable agent types for complex architectures, seamless connection with Watsonx to AI, model context protocol, and custom enterprise tools for organizations in the IBM ecosystem or those building scalable IT and HR automation workflows. AI's enterprise integration depth is unmatched among the three major frameworks. Slide 11, Exception. Critical security breach detected. This slide addresses the two failure modes that are most dangerous in production agentic systems. Risk 1, privilege escalation. The confused deputy problem. Overprivileged agents can be manipulated through compromised third-party tools. If an agent is granted broad access to financial systems without continuous privilege evaluation, a malicious actor can exploit the agent's inherited permissions to execute unauthorized actions. The output looks legitimate. The audit logs appear clean. The breach is invisible until downstream. Risk 2, structural risks, cascading failures. Tightly coupled agents with weak guardrails can enter infinite replanning loops, hallucinate shared state, and expose RAG data to unauthorized subagents. A small orchestration flaw cascades. Resources are strained. Outputs are hallucinated. Peer-to-peer agent trust collapses. These are not theoretical risks. They are the expected failure modes of any agentic system deployed without an explicit governance architecture. Building the agents is the easy part. Securing them is the architectural challenge. Slide 12. Apply patch governance guardrails. IML. The governance model. 3 guardrails must be hard-coded into every production agentic deployment. Human-in-the-loop thresholds. Define explicit decision classes that require human approval before execution. Financial transactions above a specified threshold. Production database modifications. Any irreversible external API call. These are not optional escalation paths. They are mandatory gates. Provenance logging enabled, immutable, complete. Every LLM invoked, every API call made, every data source accessed, tracked with a timestamp and session identifier. The audit trail is not a compliance afterthought. It is a core function of the agentic ecosystem. Least privilege access enforced. Authorizations must be scoped to the minimum required permissions, bound to the session, and non-transferable between agents. An agent's permissions must never exceed the permissions of the authorizing human user. This principle directly addresses the confused deputy vulnerability from the previous slide. The operator liability model is clear. Governance is not an administrative layer sitting above the system. It is a core function embedded within it. Accountability must be achieved through explainability and real-time audit trails, not post-hoc review. Slide 13. Docker Compose Up. The Agentic Enterprise Stack. This is the complete reference architecture for a production agentic enterprise system. At the bottom, the infrastructure layer. Base LLMs, Granite, GPT-4, Llama. Vector storage for memory persistence. Pinecone, Weaviate. External API tools for action execution. Composio, E2B, BrowserBase. In the middle, the orchestration layer. This is where Crew AI, LangGraph, and BE-AI operate. Each framework connects to the cognitive subsystems on the right. The reasoning and world model for strategy, the perception and grounding layer for input processing, and the action execution layer for tool invocation. At the top, the governance layer. Human-in-the-loop interfaces, provenance logging with immutable audit trails, and dynamic authorization with session-bound, non-transferable permissions. This layer sits above the orchestration layer and gates every consequential action. The synthesis insight is essential. Generative AI serves as the cognitive engine. Agentic AI provides the orchestration layer by combining rigorous system-theoretic architecture, specialized frameworks, and least privilege governance. Organizations transition from experimental chatbots to autonomous, scalable enterprise systems. Slide 14. Process completed. Exit code 0. System architecture validated. Framework dependencies integrated. Governance protocols enforced. This presentation has covered the complete path from understanding why Gen AI alone fails, through the 6 levels of autonomy, the core architectural components of an agent, the design patterns that enable real agentic behavior, the 3 leading frameworks and when to choose each one, the security risks that must be anticipated, and the governance model that makes production deployment responsible. We close with the guiding principle that should govern every architectural decision you make in this space. The current paradigm shift in AI dictates that developing intelligent agents and reasoning models is central, not peripheral. Mastery of tools and orchestration is crucial. We must build trust not through black boxes, but through transparency and control. That is the agentic enterprise.